My name is Saranya. I'm part of the Azure Cosmos database team, the product team. And I take care of primarily the Asia and EMEA part of the whole product and the business, customers, partners, and the product features related to this time zone as well. I'm very excited to be here today. Thanks for making time and joining with us here. To start off, I wanted to kind of so I guess what we want to achieve today, for example, in the next, let's give it about 30-40 minutes, is a quick whirlwind introduction to Azure Cosmos DB. This is going to be a very packed, quick session, so I'll try not to just go around the beats, but try to keep going. We are all here, me and my colleague as well, Saji as well. So after today's session, during lunch or evening, if you want to do catch up, more than happy to. But this session primarily is to help you understand Microsoft's NoSQL, new SQL database features along with the new announcements, right? So in terms of where we want to go through, what we want to cover, we'll talk really quickly about introduction to the database. We'll talk about quickly some customers that we have, maybe take a look at how it looks on the Azure portal, and then talk about some core constructs that a couple of you have used Cosmos DB knows that the fundamental or the primary decision one needs to do when they're talking of creating distributed databases that can be geo-dispersed, is to choose what is your shard or your partition key on which your data will be distributed as well. So partitioning becomes very important for cost, very important for performance, and for scalability of your solutions or in future as well. So we'll talk a little of that, and we'll talk about pricing or how do we decouple storage and compute through this what we call as request units. And then one very interesting construct is how is Cosmos DB trying to help both operational or transactional and analytical workloads as we go forward. And then of course, for those of you who have already used Cosmos DB, you will be interested in understanding what are some preview announcements or maybe other announcements that's coming forward, etc. So quite a bit, a lot of things that we have. So starting with what we see as the core tenets or what is Azure Cosmos DB here or what is it bringing on to the table per se, right? So couple of things we want to call out is it is a serverless, meaning we trying to decouple the compute and the storage. So trying to provide limitless scale. There are opportunities to optimize and make it the best TCO possible in terms of costing as well. In terms of schema or it's not a strongly relational database, right? So in a way, the way you want to think of it is it's a fluid schema, or we'll come to it what we call as new SQL, which is NoSQL with certain ACID capabilities constraints or potential relational databases that can provide distributed or sharding capabilities. So that's the convergence we want to talk about. And then really globally distributed, meaning we are able to bring, instead of bringing users close to the data, we bring data close to the users. By that, what we mean is the way we can actually smartly replicate data across wherever your locations are, the world is, and then the users can access the data from the point that is close to them. So that's really what we are talking about. So for those of us to understand this in maybe 1, 2, 3 big pillars as a cloud native database. So when I use the word cloud native, I want to be able to see that it's available across the globe, so it's geo-distributed. Cosmos DB is Azure's ring zero service. So when we use the term ring zero means whenever a data center comes up in Azure, network, storage, compute, infra, so they're basically setting up the data center. Cosmos DB is also installed as part of every data center setup. So it is actually one of the fundamental ring zero services that's available, means as many number of Azure data centers are there, so many number of locations or regions on which you can use Cosmos DB is. The second thing is, given that it's a cloud native database, people want to use it as I want to store petabyte of data, I want to store gigabytes of data. So you can use storage And also then you say, I just have few GBs of data, but I want to be able to perform 1 million transactions per 5 minutes, for example. So how can I split or separate elastic throughput? By throughput, I mean the queries or transactions or the way I want to interact with my data with the actual storage of the data. So it kind of gives you that data versus transaction or queries on the data separation. And the third most important piece is how can we bring multi-tenancy in a very fine-grained fashion with the right kind of cost efficiencies. And this is an area that from the product team we will be and we are investing as we go along as well. You will see that more and more how can we make SaaS applications more easily and literally our customers could be database administrators or company people who are the teams are database admin teams, right? But our consumers for Cosmos DB are all application developers. We are very, very thrilled in a way to see everyone who's using Cosmos DB, the best people who can see value is developers who are building applications. So for developers who are building applications, how can they create, say, specific isolation in terms of fine-grained multi-tenancy of their user tenants, of role-based access control, governance modules on which they want to provide certain kinds of cost versus usage versus telemetry isolations, then performance isolations where one tenant is actually very high in terms of usage with others. So those are things that the system will support and also improve upon as we go forward. Okay. This is more like the layer cake view of Cosmos DB. Anywhere if you go and look up Cosmos DB, this is what you will see. I'd like to just spend some time, maybe just a minute, to kind of explain or to talk through the basic tenets on which the Cosmos database has been built. It was built, I think, about actually in Microsoft, to give you a history, about 15 years ago is when this project started, called Project Florence. And about 7-8 years ago is when they named it as what they call as document database or document DB. It was purely saying, I'll give you a JSON document and you can read, write on JSON document. And if you want to just directly read and write it with an ID, which is a unique across each document, then you're using it as a key value store. But then if you're going to read and write across any other, then I provide you query access. And what kind of query access can I provide? SQL-like query access. So in a way, they started calling it SQL API. Happy Diwali, folks. SQL API. So the way they called it was for SQL API, but it's not SQL Server. It's a NoSQL database providing SQL-like queries. But then essentially what we are landing is JSON read writes, right? Anyway, so that's how it started 8 years back. At some point, the way we announced or rebranded or brought or solidified Cosmos DB was based on these tenets that you see on the layer cake right here. The basic tenets being directly through a command line or through the portal with just a click, we should enable turnkey global distribution. In India, we have 3 data centers in Chennai, in I think West and Center. So one's in Pune, one's in Bombay, the couple of data centers in India. You should feel comfortable to load balance by immediately choosing where we want, or even, you know, say in Korea, Australia or Japan. So it's available for turnkey global distribution as we speak. We spoke about elastic scale out of storage and throughput. Also guaranteed low latency at P99, means at the percentile, 99th percentile, Cosmos DB for point reads and writes, we guarantee single millisecond read and write latencies, right? So that's something. There's also interesting constructs around consistencies, and we probably won't have too much time to talk about that. But then the point I want to leave you with is Cosmos DB came up out of academia. And academia kind of brought in to say we want to talk about NoSQL data and distributed data, then there is no way, or there is, it's not, physics would not allow an opportunity to have consistent data which is always available, which can also have sharded database, right? So that's basically the CAP theorem which is out there, which means given that this is a geo-distributed or sharded database, That means partitioning is something that we need to do. We need to have trade-offs between availability or latency on which we want to collect our data versus what are the consistency in terms of how data is stale or real based on our user access. So there are a bunch of well-defined consistency model. Today academia I think brings up about 57 to 59 consistency models. Cosmos DB brings about 5 consistency models that we can bring up, and default consistency is what we call as session state consistency. That means for a session ID, we provide monotonic reads and monotonic writes on the database. That means if you are a user who are writing data, you would read the data that you have written. But that's default. Outside of that, there is strong, eventual and other options as well. Financially backed SLA, or that's something that we provide as well on that side. So just to take a step back, Cosmos database found across all data centers on Azure, built on these main tenets on which we want to prove our precedence. But then finally, if you look at it, how are we exposing it out to customers, to developers, to other users? We are exposing them in multiple data structures which is out there. All of the data is actually sitting within the common storage engine in our Cosmos DB's backend storage engines, but it's exposed out either as a key value store, column family stores, document stores or object stores, graph components. And this October in Microsoft Ignite, we announced support for an open source relational PG, Postgres, as well as one of the APIs for Cosmos DB. These are all called APIs, mainly because, as I said, developers are our consumers, and developers are using the database in the data structure that's most convenient for them based on their skills, based on their uses, and basically on the guarantees that certain wire protocols provide. So in that way, in terms of these APIs, we do have what we call as our core, which is the NoSQL API. Previously, it used to be called a SQL API. So for all of those Cosmos DB folks, we have rebranded, finally brought better clarity, calling NoSQL API. And then we do support third-party APIs such as MongoDB, open source APIs such as Cassandra, Gremlin, and PG API as well. So all of those are available right there. This was a rather long introduction to Cosmos DB, but I wanted to kind of take a pause given that this is basically an overview and a new announcement session. Wanted to take a step back and see how the journey has kind of been when we look at SQL, NoSQL. So couple of things that I want to highlight here for those of you. Let's go, given the interest of time, let's go a little slides ahead and try to bring in the nuances between the NoSQL or new SQL databases. How many of you have actually heard of this term new SQL today? Not really. Distributed SQL? Couple of you, yeah. So if you look at it for the last 30 years, relational databases, SQL, Oracle, all of them were pretty rampant, right? However, in the last decade, over 10 years, NoSQL databases, MongoDB, CouchDB, today FaunaDB, a lot of those are also available right now. So what is the big difference? The relational databases provide you strong schema and ability for you to work with a defined schema. So you first define the schema and then you build applications and make them to work to that schema, which means you'll bring classes, you'll create your serialization, deserialization based on your schema, and then you would be able to create joins and then surface out on your apps. However, if you look at the NoSQL world, you will start with your application development first. You will say, these are my top queries, this is how my app should look like. Hey, for this app, I need a backend object which contains these 20 properties. So it's basically fluid schema. So you'll go create objects which are primarily, in this case, JSON objects, which will have property with multiple values that you have, and then you go and create that. That's your NoSQL component, right? So at that NoSQL component, as you see, there could be key value components, meaning one key is the ID, value 1, value 2, value 3. Value 3 can be anything. One of the values can be free-flowing text, value can be a nested object, value can be an array. It could be any object data type that you want, but it's essentially key value stores. Column family databases, similarly. Document databases are purely JSON documents. Graph data components are nodes and vertices with inbound and outbound edges. So there are multiple data structures which is potential when we talk of NoSQL databases. Now, where we are heading to also today that we see is the relational databases are also trying to provide those guarantees of flexibility that or base characteristics of what the NoSQL components are building, which means basically ability to shard, ability to provide consistency across your data components based on the need of the users. So, when we say distributed relational databases that are distributed based on a particular shard key and which can perform good strong query pushdowns back to the storage engine and read back, those are, I would say, like the North Star or the Nirvana state that many database companies or database developers are aspiring towards. So, if you go and look up new SQL components, you will see a couple of these things. So, with that quick recap, Cosmos DB, as we said, couple of like the value proposition of Cosmos DB really is SLA backed latency. So, providing single millisecond read and potentially write latencies, ability to run mission critical apps as we said, and then simplified app development. Yesterday's session was talking a lot about our SDKs and how best we could access that. That's something that you should definitely go back and look. And then ability to manage, it's a SaaS or a platform as a service component. So, it's a mix between those in certain features that we want to provide, right. So, those are the 4 main tenets. Let's keep going forward. So, today operational needs of databases today, providing requirement to have high throughput across batch and streaming and real-time data with real-time indexing, global distribution with active-active setup, apps to perform real-time CRUD with developer-friendly NoSQL API components. As you're scaling, obviously you don't want to have, or you want to have very minimal downtime as you're scaling your backend data components, and you want to be able to have a good SLA across availability, across throughput, across storage consistencies, so on and so forth, right. So, these tend to be when we look at large, say online e-commerce sites or healthcare or finance or oil, energy and gas, couple of those sectors, these seem to be operational needs today. And over and above that, as we have just seen, you would have realized Cosmos DB in a way is multi-model. You have multiple accesses of data structures, although in reality you kind of choose only one. It's not that you can choose a column family and then move to a document from that, like you can't go from Cassandra to a NoSQL, etc. Today the interoperability is mainly from Graph and our NoSQL because both of those are first party, but then essentially you have the option to choose multiple models, right. And then we spoke about developer friendly components, auto indexing and auto scale. It's something that's super cool as well. Every component on Cosmos DB is automatically indexed unless you say not to. But then it also can improve performance if you are sure that you don't need certain properties to index. You have to manually go ahead and remove those indexes as well. That's top use cases when we talk of Cosmos DB, situations where we have globally distributed database, etc. So, when I look at Domino's Pizza today, if you order anywhere in the world, for example, it serves Starbucks coffee is served from Cosmos DB. So, situations where we have these kinds of globally distributed data. For example, Azure portal, the entire Azure portal sits on Azure Cosmos DB. The teams on which we chat is based on Azure Cosmos DB. So, there is a lot of usage that we see where there is globally distributed applications as well. The second thing is building real-time customer experiences because of the lowest latencies that we see. Multiple online e-commerce sites which require personalizations, which require things where they are near real time and they want very quick CRUDs for both catalog browsing, for checkout, for transactions, they tend to use Cosmos database. And then for even certain gaming and online e-commerce, we said that. This is an area which is there today and we probably want to invest as we go forward. How to make it truly serverless with simplified development. Personally, coming from the product team, we feel there is scope for improvement there from our side. But we also see this is a huge area where customers find it valuable. So for example, small companies who want to start with 10, 20 users, 100,000 users, today have a free tier. They have up to 1,000, what we call as request units, and about 50 GB of data that they can start for free forever on Cosmos DB. So they can keep trying, and as it scales, then they actually scale up. And there are multiple ways to create a very strong serverless architecture as well. Creating a HTAP, a new terminology again. As I said, this is going to be a whirlwind session, so I'm just going with terminologies here. It's HTAP is Hybrid Transactional Analytical Processing Systems. That is one system where one HTTP fully qualified domain name or a URI that you provide, based on an SDK access, you're hitting the transactional store or you're hitting the analytical stores. In a relational world, transactional stores are stored as rows and columns and normalized tables. Analytical stores are stored in MPP architectures in a SQL data warehouse, etc. If you come to the big data world, the rows are stored as entity stores, as we spoke in Cosmos DB, and then the analytical stores are stored either as Parquet format or BigQuery, big data formats that are available. So in a way, HTAP workloads will help you to have one consolidated customer, consumer or a developer access where you could use your direct either Spark jobs or your SDKs to be able to actually hit one URL, but at the back end, we will either bring analytical store or your operational store data back for you. So that's there. And finally, as I said, we support other open source and third party native wire protocol supports, MongoDB, Cassandra, and just announced PG API, Postgres API as well. Right. So this is way too many very cluttered slide, but really if we want to look at these four: real-time telemetry, real-time recommendation engine, mission critical geo-distributed application, and NoSQL data component. Quick rundown of what we mean as real-time telemetry. A lot of IoT customers, IoT developers find use in Cosmos DB for its latency and telemetry, and being able to use for certain kind of OLAP queries based on that data. So that's here. And then when we look at real-time personalizations, there's a hot and a warm or a cold path of access. Cosmos DB primarily targeting the hot path, wherein operational CRUD transactions are going through Cosmos DB on the hot path that we see there. So that's one part of the architecture rundown as well. Globally distributed apps. So if you kind of see, there's one thing with Cosmos DB is it actually coexists with other Azure services or non-other Azure services as well. But really, it's one component in an end-to-end architecture which is out there. I wanted to call that out here because at the end of the day, here, for example, you're using an Azure Traffic Manager, and which is talking to multiple app services, in this case Azure components, multiple load balancers or web servers which are geo-distributed, etc. And they are all talking to one integrated backend which is multi-tenant, which is Cosmos database. Right? This can be any other components across any other clouds as well, but given that a data component is tightly integrated to the app ecosystem or the middleware or an end-to-end architecture is something very critical. So for us to give that responsibility and that power to developers to choose that and being able to go beyond just the app creation to controlling and facilitating the backend data components is something that Cosmos DB's target or claim to fame is, right? And then we have options to migrate. So in terms of today's customer that we see, online, retail, e-commerce, we can say that. And I can also openly communicate today, we got this approval is also very large e-commerce sites including Walmart, etc. are on Azure Cosmos DB today, pretty much fully for multiple of these use cases that you see. Manufacturing, we have Toyota, Mazda, a lot of these customers are on Cosmos DB. In logistics, again, in supply chain management, we have financial audit trails, risk analysis, and then certain gaming components as well. Here are a couple of our customer names that we have. And with that, we will have like a very, very quick demo of how Azure Cosmos DB can potentially look like as well. And it will conform to all of the Azure's constructs when we look at the Azure portal. So you will go ahead and create a new resource. You'll go to your database components and you will go and create an Azure Cosmos DB component, right? And here, your fundamental choice, as I said, there are two things that one needs to choose when they're choosing Cosmos DB. One is what is your data structure which you want to access or create your data component. Do you want to use directly a JSON, which is our NoSQL, or Mongo compliant, or Apache Cassandra compliant, Azure Table Storage, Gremlin, or as I said today, we support PG compliant as well. So as you select one of these, then the next most important and irreversible choice that we make is the choice of the partition key or the shard key. In this overview session, it might be really hard for us to spend a lot of time, but if any of you are interested to spend some time, probably the most important thing that you want to take away from this session is understanding what is partitioning, how are distributed systems. You can forget about Cosmos DB, but how do distributed systems, distributed storage systems, distributed compute system, how do they shard their components? It's fascinating to realize what are the various sharding technologies, and then we will appreciate the fact that you cannot choose one shard component and then change that shard component, right? So in any data component, choosing a sharding key or the sharding component is probably the most important decision that you want to make. So this is a standardized way, and this complies with multiple Cosmos DB or multiple Azure's services, such as you say, we have backup, networking, which global distribution you want to support, encryption and support that we want, and then we can go create your Azure Cosmos DB component. Once you create it, you get a very familiar screen that you see here, and your data explorer is essentially where you will go and create this data. And if you create a Cosmos DB account like the one we just created, and if you go to this overview tab, this is a fully qualified unique name. So this has to be unique, and this is what will hit Cosmos DB. When you create this unique name, it is a logical name. There is no physical resources which have been allocated the background. It's more like a metadata store in our system tables that we allocate for you. And this is what we call as a Cosmos DB account. The hierarchy of the system hierarchy that works is once we have a Cosmos DB account, we can go ahead and create a database and then containers or collections under this database. So you have an account, then you have a database, and within the database, it's either containers or collections. It's just the same thing. We just use multiple, or in Cassandra, you call Cassandra tables. In Postgres, you would call tables, but essentially that's the third denomination. And only at that point, we allocate backend SSD backed compute and storage components to your account, right? So till that, there is nothing actually physically allocated to you. So in this case, if you open up the demo database, it probably will have a couple of collections, and then based on the internet, we can see once those collections load up, we'll see that each collection will have items on that collection, right? So that's pretty much the system hierarchy there. As we talk of this system hierarchy, what is important is, as we said, at the back end, when we actually allocate these collections or containers to you, we are actually allocating a container similar to a Docker-based container or something. That's our internal implementations. That's where we allocate. And each of the collection that you create is geo-distributed, which means that collection can be, if it is greater than 50 GB, they are sharded. This is horizontally sharded, and each of the shard is 4 times replicated. So automatically with Cosmos DB, you get a 4-node backend replica, so high availability is kind of guaranteed to a point. And then they are also, depending on how do you geo replicate, your data is replicated outside. So these 4 replica set, one is the leader, there is followers, and then there is a forwarder which will forward to another region. So imagine you have Chennai and Mumbai, so you have 2 regions and you have a Cosmos DB database. You need the data to be synchronized or consistent based on your choice of your consistency. If your consistency says strong consistency, then every time you go and do a write request, you will get an ACK back only after committing to the data center, which is remote as well, and then coming back with an ACK to the end user to say it's coming. You choose eventual consistency, it's going to do a quorum commit here. Within the local commit, it will be strong, and then for the other region, it is going to go ahead and then have eventually consistent across data centers. But always within one data center, we will ensure, because it's a 4-node replica, we will ensure there is strong consistency in a single region. So in a way, that's how the system operates, right? So this is one of my favorite slides here, which kind of tells us that when we talk of planet Earth, we have multiple Azure regions. Cosmos DB is available in each of the Azure regions, and that means it's available in every data center. I shouldn't be saying this, but hypothetically say in Singapore, I am based out of Singapore, that we have 3 Azure data centers, and I didn't tell you that because we are not supposed to say how many data centers are out there. I'm just saying hypothetically assume that there are 3 data centers. Then that means that that is only one region, but there are multiple data centers within the same region. So in a way, when we guarantee zone availability, we will say that Azure Cosmos DB is available in 2 infrastructure or 2 different buildings within the same region. So hence you get zone availability as well on Azure, right? So that's your next stamp. From there, within one data center, we have rows and clusters of various hardware machines, and that's where we call as stamps in which we, and these stamps are based on 2 crisscrossing flows. One is called this fault domain, which is a single point of physical failure like network, cooling, power, any of those. And then upgrade domains, which are more a software upgrade single points of failures based on VM upgrades and host connections and so on and so forth. So that's one part of this fault domain. And within the fault domain, you see there is the actual cluster. Cosmos DB in turn sits on Service Fabric, which is not available outside publicly right now, I guess. But many of Azure, it's similar to Azure Kubernetes services. It's an orchestrator for across multiple collections of containers, but it provides something like service mesh kind of capability, or even more actually, very fine-grained capability. But then that's our cluster ring where we are able to load balance across multiple clusters, right? Each of those nodes in this cluster is the actual container, and this is the collection that, or the container that you create. Some part of the sharded component is where actually it lands up here. This container then contains the most important piece, which is our database engine. And in this database engine is where we have our core database storage engine components, query processors. This is our patented BW tree is the indexer. Actually, Cosmos DB's fundamental patent is for the indexing for its latency and speed. So that's our index manager there. And then there's also a resource governance, which means every single request you send on Cosmos DB, it will know how much of CPU IOP memory that has been calculated. So it can give you a truly like a SaaS or a serverless kind of output in terms of the cogs that takes to run that operation on the backend server, right? Sometimes people say Cosmos DB is kind of cost expensive in the past. We've heard that as well, and we've made a lot of improvements to that recently. I can talk to you, and I can also take your feedback as we speak. But then the point I'm trying to make is it's one of those services in Azure which is kind of cogs neutral when it comes to Azure. Like if you look at certain Azure services, this resource governance module is kind of flaky. In Cosmos DB, it's so accurate that we will have a clear idea, and probably as we keep making the product more better, we will know how much density can we allocate and all of that. So these are internals for those who are interested to kind of just understand. I'll take a pause. Any questions till here, please? Right, the question is really how, when you go and create a Cosmos DB account, you have 2 options to create. In fact, that's what we are probably going to talk about next. So let's go into that topic, right? And that way we will know what we are talking about as well. I'll come to this question in a second, because I don't think we are going to spend too much time on partitioning. It is a very exhaustive topic. The only 2 things I'm going to let you go today is partitioning is most important in any globally distributed databases, so we need to partition our data. And when you partition your data, you have an option. We need to understand there is physical partitions at the backend in Cosmos DB. Each physical partition today is 50 GB. It can become more tomorrow. But as consumers, you don't need to know what is the physical partition size. As consumers, you are developers, you need to worry about your logical partition key, which is your shard key that we call, which is your first thing that you choose. And this shard key is based on which you will actually, all the data is going to be co-located and sharded in our backend database. The only point that you probably want to understand there is, in this case, as you see, right, you have a data of 150 GB, which means, look at this, you have data which is allocated across 3 physical shards. So this is your partition set of 3 physical shards, right? Here. You have all of these region 1, these are your physical shards. So here in this case 50, 100, 2, 3. So there's about 250 GB of data in this picture, for example, because there are 5 physical shards, each can take about 50 GB. Now you're putting it across 3 regions, US, India and Korea, for example. So then this is called a partition set, and this is your data is replicated across their respective physical counterparts, and they are also maintained across in their particular region. So this is how logical to physical partition mapping happens. It's a little too much to take in like the first go, but this is a very interesting and important construct. Let's go forward to understand a little bit about your question, which is about how do I choose my options and how do I choose the way I want to pay or way I want to provision my Cosmos DB account. As I said, sharding is very important. I want to just kind of call out this one small thing which I've put up in this last end of this slide here, which is don't be afraid to have large number of partition keys. Partition keys are logical keys, they are not physical. That means if you have 10 partition keys, doesn't mean you have 10 physical servers at the back end. We will host multiple logical partitions within one physical shard and split the physical shard on Cosmos DB end. The minute you have more logical partition means that the data is co-located accordingly. If you limit it to the limit, it means every partition key is unique, then your Cosmos DB account becomes a key value store, lookup store. It actually becomes a key value lookup store where your key is your partition key. For example, if you have a unique customer ID, you can choose customer ID as a partition key, then every single customer ID and assume that it's got only one record or one document, then that becomes like a key value store. You can keep, so question is, can we keep adding regions? Yes, at any point of time you can add the region and the data will automatically synchronize into another region whichever you add, etc. That is possible. So with that, question 2, request units and elasticity here. So before we go to this gentleman's question, the most important construct that I want to highlight here is there is a currency on which we access and talk to Cosmos DB, which is called request units. So it's basically a measure of CPU, IOPS and memory that is required to perform your queries. So that is what is critical for us to understand. So for example, various operations like HTTP get, put, post, delete operations will consume certain amount of computing resources that is split up as a request unit or an RU at the backend, right? So for us, when you use Cosmos DB, you will go ahead and say, I want to have a maximum RU that I want to specify. And any number of requests you make above that RU, that's where you will get throttled or your access will not be allowed by the system. If it is lower than that, then the system will allow access to this. So in Cosmos DB, when we go and provision Cosmos DB, you can provision it in 2 ways. Either you can say, I want to have a provisioned RU or provisioned throughput. That basically means I want to be able to tell you how much RU I want. Or you can go and say, I can choose in serverless mode that I have no idea how much RU I want. So let's just run, and if how much ever RU that query takes, you add it to my bucket. how much ever RU that, and the minute I reach 5 million RU, I will pay so many dollars. The next 5 million RUs, I will pay so many dollars. So that's purely serverless mode of accessing. So that's one way of paying for Cosmos DB's RUs. The other way of paying, as you asked, is what we call as provisioned throughput, etc., where you specify what is my RU. So in the provisioned throughput, you have two options. Either you can do manually provision and say I want 1000 RUs per second. So every second you'll have a bag of 1000 RUs which you can use. If you use full 1000 and want to go beyond, you will get throttled. If you use less than 1000, it will go waste in a way, right? Or you can choose auto scale. Auto scale is to say that I'll say my highest RU limit and I will be consuming only the actual RUs I use below that. Above that, I will be throttled and I can go up to 10% of that below. So those are my two options when I talk of request units, and then I need to make that decision when we go ahead and decide. There are some interesting constructs like you see here, which is we have adaptive RUs and burst capabilities today, which means that if you're not using the RUs that you've allocated, you can accrue it for a period of 5 minutes, and suddenly one query comes that increases more than the top level, can consume that and go back. There are other things that we are working around here called what we call as adaptive RU that you see here. And by adaptive RU, what we mean is if one of the partition is getting hot and other partitions RUs are getting kind of wasted, we are able to move those. So these are things that will come out which will help Cosmos DB address cost constraints or RU hot partitions, and these are actively being worked upon as we speak. Right? I wanted to also talk to you about two things before I close today. One thing is Cosmos DB being able to provide operational and analytical transactional analytical processing system or HTAP system. So how does that work? In Cosmos DB today, we have a row-based system, that's our containers, collections or tables that we spoke till now. And here we automatically sync it with our analytical store, and this is inside within one fully qualified domain or URL access. So it's within Cosmos DB, we are able to duplicate auto sync our systems, and then externally we expose that using what is called the Azure Synapse link, which is a Spark based connector into the Spark compute system, which is Azure Synapse Analytics. Today we support Synapse Analytics, but there are cases where we support other computing environments such as Azure Databricks or homegrown analytical stores. Today it's based on case by case, so if there's need, you can raise a support request or just write a note to one of us, and we can go forward with such requests based on your need that we have. So this is one thing I wanted to talk. And then the second thing I wanted to talk is our preview announcements, because there are a few people who have used Cosmos DB, and I know you folks will be interested in our preview announcements. And on that is what I was searching in the beginning, the initial slide that I wanted to say is relational database for the last couple of decades, NoSQL database in the last one decade that we have seen, and today the convergence that we see in what we call as distributed SQL components, and that is our offering, which is the Azure Cosmos DB for Postgres SQL. This was announced about one and a half weeks ago. It is a GA product today where you can have relational, open source relational database workloads, but having ability to scale, like sharding a Postgres database across is possible, and also have cross-region replicas, and with a gap of 2 weeks gap to catch up with the latest PG release is a promise of this component. So anytime there's an open source PG Postgres update within 2 weeks, Cosmos DB's distributed PG will comply with that. So that's how and that flexibility we have with Postgres because it's open source component. That flexibility we might not have with Mongo, for example, because it's a proprietary component. I'm just kind of highlighting that there. But then, yeah, so those are certain announcements that we have. And in the afternoon session, we'll talk about certain security components, that is like RBAC and other capabilities that we have as well. At a high level, I wanted to highlight to all of those folks who are new to Cosmos DB, we are working on cost effectiveness. We've heard loud and clear that while it's a good premium product which just works, and as I said, with so many large customers and out there today, like Tokyo Olympics last time was on Cosmos DB as well. We can go on and giving you references of large customers. But we want to make Cosmos DB effective for smaller customers, for customers who want to start small and then scale and without feeling the cost pinch. And there are a lot of technical, as I said, burst, adaptive, partition match, hierarchical partition keys we didn't speak about today, true serverless limits increase. So all of those will help the cost effectiveness components. Also, we want to ensure it's safe in terms of security for mission critical applications. So there are a bunch of security components we will talk in the afternoon session. And then definitely for developers to make app development much better across various APIs, there are multiple features that we support on that front as well. One of the call-outs, look out for GraphQL supports that will be coming out as well. Then there are components around materialized views and certain other features that you see here. With this, I will close today's session. It was more as a really quick run through worldwide wind across Cosmos DB for mission critical, for cost, and for flexible application development. This deck will be available for all of you, so you can have access to multiple resources and links that we have sent out here. The most important is the main documentation, which has pretty much all our limits, and it's pretty comprehensive there. So that's our resources. Thank you, everyone.